For the last section in chapter 4, we will tackle tangent and cotangent graphs. Again, we're out of order. We did this after 4-4 because those 4-4 graphs, secant and cosecant, made sense to follow up right after sine and cosine. Our graphs of tangent and cotangent are unique. They have a different shape than what we have been using. If you look down here, you can see my tangent and cotangent function graph looks like a cubic function that has been repeated. Because remember, these are periodic functions, so this would be one period, one cycle of tangent. If we did lots of cycles, it's going to look like this. Okay, now this definition for vertical asymptote is here because I wasn't paying close enough attention when I was putting these together. We should have defined that on 4-4 because we did it first. But you guys know from college algebra, a vertical asymptote is just a vertical line that occurs where the function is undefined. The graph approaches this line but never intersects. It approaches the vertical asymptote, but it never touches it. Excuse me. Okay. Now, with sine and cosine, their domain was all real numbers. No values were undefined because for sine and cosine, my denominator was r. When I flipped those and I put an x or a y in the denominator, I had to pay attention where those values were 0, because at those locations my function is undefined. The same is going to be true for tangent and cotangent. Now remember, tangent theta is sine theta over cosine theta, so it's going to be undefined where cosine theta, or cosine x, is equal to 0, because that is my denominator, that cosine function value. What that looks like for our domain here, well, cosine is 0, cosine is 0 at my odd pi halves, 1 pi half, 3 pi halves, and then as I keep rotating around. So at the odd pi halves is where my tangent function is undefined. So my domain, all values x, such that x is not equal to k pi half, where k is an odd integer. That should sound familiar, right? My secant domain. Range of tangent, all real numbers. So things to note about your tangent function. Tangent is an increasing function. Positive tangent is an increasing function. You start low, you finish high. For each of those curves, you're going to start at negative infinity and move up to positive infinity as your x coordinates go left to right. So it's an increasing function. Tangent is undefined at the odd pi halves. So that gives us our locations of our vertical asymptotes. Right here, vertical asymptotes at the odd pi halves. That's my starting place. My value for a, instead of an amplitude, it's going to give me a quarter function value. So you see that I have my cycle here. I cut it in half, and then I divide each of those halves into half so that I have 4 equal intervals, just like we always do. Well, my value for a is going to tell me where those quarter function values are going to fall. So right here, not the midway mark, but the quarter function mark, that's my value for a. And then the center point is my center. So when I'm graphing a tangent function, I find 2 consecutive vertical asymptotes, the quarter function values, and center. Since tangent is increasing when it's positive, my quarter function values are going to move in that direction. So that tells me where I will have a negative one, where I will have a positive one, or if I have a different value for A. Notice that when we graph our primary cycle of tangent, we balance it on the asymptotes negative pi half, positive pi half, instead of doing pi half, 3 pi halves. That's not the way it absolutely has to do. It's just the convention. This is where we start. This is our starting place for graphing tangent. So the graph of tangent is discontinuous. It has gaps and breaks. It has vertical asymptotes in the form of the k pi halves, where k is odd. K is an odd integer. It's from my domain. It has vertical asymptotes there. The x-intercepts are in the form of x equals n pi. So this would be 0 pi. I'll hit the center at pi, at 2 pi, etc., etc. You can see that there. You've got a center at negative 2 pi, at positive 2 pi, at 0, at negative pi. The period for tangent is just pi, not 2 pi. That's something else to make sure that you make note of. For tangent and cotangent, they are periodic over pi radians. Now here's why that happens. Because I am using x and y values for my tangent function values, I am able to go through the entire range of possibilities from negative pi half to positive pi half. I do a full cycle of tangent values in that half rotation. And then I do another full cycle from positive pi half to 3 pi halves. For cotangent, when we get there, you will see that you do a full range of values from 0 to pi or from pi to 2 pi. Either way you want to look at it, tangent and cotangent are periodic over pi radians, not 2 pi radians. So that's a different starting place for these two functions. As I mentioned before, the graph has no amplitude because it doesn't have a maximum or a minimum. It goes up and down forever, but that value A does give me that quarter function value. So that's my value for A. The graph is symmetric with respect to the origin, so it is an odd function. Tangent of negative x is the same thing as a negative tangent of x, or the opposite of tangent x. Remember, cosine and secant are only two even functions. The other four functions are all odd functions. I just grabbed the identity sheet because I thought that was on your identity sheet somewhere, your even and odd functions. But I don't see it on this copy. Okay, let's move on and let's talk about cotangent function. The major difference between tangent and cotangent, two major differences: where the asymptotes fall and the direction. I see that with tangent I have an increasing function, with cotangent I have a decreasing function. With tangent, my consecutive vertical asymptotes fall on those odd pi halves. With cotangent, they fall on the full values of pi. So 0 in pi, 2 pi, 3 pi, etc. are going to be where my vertical asymptotes fall. Let's go ahead and get this filled in for your notes. Okay, graphing cotangent. Cotangent theta is cosine theta over sine theta. Therefore, cotangent is undefined wherever sine of theta is equal to 0. And sine is 0 at my full values of pi. So my domain of cotangent, x such that x is not equal to n pi, where n is any integer. So my full values of pi. Range, all real numbers, just like tangent. Cotangent is a decreasing function. My vertical asymptotes fall at those full values of pi because that's where cotangent is undefined. So that's a vertical asymptote, that's a vertical asymptote. Again, my quarter function values are found by that value of a, so where a is 1, my quarter function values are 1 and -1. And then that center point is my center. All right, cotangent is discontinuous at n pi, where n is any integer. That gives me my vertical asymptotes. The x-intercepts come at the pi halves, those odd pi halves. K is odd, period is pi, same as for tangent. Period for tangent and cotangent is just pi, not 2 pi. Again, the period is going to be altered by some value b, but instead of 2 pi over b, it's just pi over b for tangent and cotangent. The graph has no amplitude because it goes up and down forever, but that value a does give us those quarter function values. It is odd, symmetric with respect to the origin, so if I plug in a -x, it's the same thing as the opposite of the function value of x. All right. Here's your steps. For those of you who really like to have that all written down in one place, this is for you. Here we go. When I'm graphing tangent or cotangent, I first determine the period. Remember that period for tangent and cotangent starts out as pi, and then it's changed by a value of b other than 1. This lets us identify 2 adjacent vertical asymptotes. If I'm dealing with tangent, remember that your asymptotes start at the odd values of pi half. So you're going to set this up so that you've got b of x is equal to a negative pi half or a positive pi half. And I'll show you how we're going to make use of this when we get ready to do our first graph. For cotangent, though, cotangent is undefined at the full values of pi. So when I set up to find my 2 vertical asymptotes, I set it equal to 0 and pi. You can see that when I solve for x, I'll be dividing all of this by b, just like it says over here. Okay, then I sketch the asymptotes onto the graph. Between the 2 asymptotes, I divide my, my space into 4 equal intervals. And I evaluate the function for first quarter, third quarter, and midpoint. The first and third quarter values are given to me by whatever a is. That midpoint is my center, so if I have c, that's my midpoint value. And then I connect them with a smooth continuous curve that approaches those vertical asymptotes. Remember that positive tangent is increasing and positive cotangent is a decreasing function. Positive tangent is an increasing function, positive cotangent is a decreasing function. Okay, so get those steps where you can refer to them, and let's do some graphs. Our first graph is going to be a positive tangent function. So positive tangent is an increasing function. That is the first thing I know. The second thing I notice is that my value for a is 1. So that's going to give me my quarter function values. A is going to be 1, -1. Not a max or min, not an amplitude, but that's my quarter function value. Then I need to determine the period of my function. The period for tangent or cotangent is pi over b. Here, b is 2/3. So pi over 2/3. To divide by a fraction, we multiply by the reciprocal. So my period is 3 pi halves. Okay, that 3 pi halves for tangent, we're going to start out split across the y-axis. So we expect we're going to have vertical asymptotes on either side of my y-axis, unless I have a phase shift. So we're going to we found our period. Now we're going to find our vertical asymptotes. For tangent, the starting place for those vertical asymptotes is bx, not a. Bx is equal to negative pi half or positive pi half. And you can kind of do these at the same time here in a minute. I'll show you how, but we're going to start here. I use my value for b, that 2/3, so that I have 2/3 x is equal to negative pi half, and I have 2/3 x is equal to positive pi half. Well, to solve for x, I'm going to multiply by the reciprocal, that 3/2. I'm working this for both equations, right? So anything times its reciprocal is 1. This solves x equals, over here x equals a negative 3 pi fourths, and over here x equals a positive 3 pi fourths. That's the two equations for my vertical asymptotes. So let's finish setting up our graph. We're going to have negative 3 pi fourths and a positive 3 pi fourths for my vertical asymptotes, right there. Two consecutive vertical asymptotes. And we are going to divide the space in between those two asymptotes into 4 equal intervals with their center. So there's my quarter function values. What's half of 3 pi fourths? Well, 3 pi fourths divided by 2 or times 1/2 is 3 pi eighths. So those are my quarter function values on the x-axis. Make sure you are labeling things. Okay, where does my function go? Well, positive tangent is increasing. My quarter function value is going to be whatever a is. A is 1. Center is going to be at 0 because I don't have a vertical shift. A is 1, so I'm going to go up 1, down 1, and I need to do it in whichever order I end up with an increasing function. So I'm going to start low. My first quarter value will be at -1, and I'm going to finish high. My third quarter function value is going to be at +1. And when I connect those, it needs to look like a cubic function curve. Ta-da! What if I needed to do more than one cycle? That's one cycle. What if I wanted to do more than one cycle? Well, my period is 3 pi halves, so I need to add 3 pi halves to this. So 3 pi fourths plus 3 pi halves. Well, 3 pi halves is the same thing as 6 pi fourths. 3 pi fourths and 6 pi fourths is 9 pi fourths. So out here, my next vertical asymptote would be at 9 pi fourths. I would divide this into center and quarters. My center is at 0. My quarter function value is 1, so -1 and then +1 because I need it to be increasing. And I've got a second cycle. I can just keep repeating as long as I need to. Alright, let's look at this next one. This one is a negative tangent function. Positive tangent is increasing. That means if I have a negative tangent function, I have a decreasing function. Negative tangent is decreasing. I gotta write this down so I don't forget to graph it that way. Alright, what else do we have? Well, we have that a is 1/2, so that's my quarter function value. We have that b is 2, so that's going to affect the period. We don't have a phase shift. We don't have a change in center. Okay, we're graphing tangent. Tangent is balanced across the y-axis. I know that my amplitude, not amplitude, my value for a is 1/2. So I'm going to go up to 1/2, down to 1/2 for my quarter function values. Period. Tangent period starts out as pi over b. So here b is 2. Period is pi half. I need to figure out where my vertical asymptotes are. I'm going to start at bx equals positive or negative pi half because that's my starting place for my vertical asymptotes for tangent. Remember, we're told that our starting place for vertical asymptotes for tangent are at the positive and negative pi halves. Notice I kept it stacked this time. I promised I'd show you how to do it with it stacked. B is 2, so that's 2x equals plus or minus pi half. If I divide by 2, or I can think of it as multiplying by a 1/2, either way, it's the same thing. Half of 2 is 1. This gives me x equals plus or minus pi fourth as my vertical asymptotes. So if I put a vertical asymptote here and a vertical asymptote here, that is at a negative pi fourth and a positive pi fourth. The difference between negative pi fourth and positive pi fourth is 2 pi fourths or pi half. That's my period. So I have center, quarter function values. Well, center's at 0 because I don't have a vertical shift. Quarter function values are going to be at 1/2 and negative 1/2. Negative tangent, decreasing. There's my quarter function value. Decreasing means I need to start high and finish low. So this quarter is at positive 1/2. This quarter is at negative 1/2. There's my curve contained by my vertical asymptotes. Oh, I didn't label my quarters. Half of pi fourth, 1/2 times pi fourth is pi eighth. So that's a negative pi eighth for my quarter function values. So this point is at negative pi 8, positive 1/2. This point is at positive pi 8, negative 1/2. Those are my quarter function values. Alrighty. Again, I keep wanting to ask what questions you have. You are not here to ask, to tell me. So we're just going to move on. Here's our example. 3 cotangent 1/2. Okay, so we're switching. We're doing a couple of things different because we've got cotangent. It's a positive cotangent. Positive cotangent is a decreasing function. And if you have trouble remembering that, you grab your sheet where we set all these things out. Positive cotangent is a decreasing function. Okay, so what have we got? We've got A is 3, and I've got B is 1/2. A is 3, B is 1/2. So A is 3, 1, 2, 3. 1, 2, negative 3 on my y-axis. I don't have a value for center. I haven't shifted my center vertically up or down, so my center is going to be at 0. My period for this function is pi over b, pi over 1/2, multiplied by the reciprocal, and I get a period of 2 pi. Now, when I start my vertical asymptotes, I am doing cotangent. Cotangent is not undefined at the odd pi halves. It's undefined at the full values of pi. So my vertical asymptote equations start differently. They start at 0 and pi. Then I plug in my value for b. And to solve for x, I'm going to multiply by the reciprocal. One half of 2 is 1. That solves for x. 0 times anything is just 0. But 2 times pi is 2 pi. So that's the location of 2 consecutive vertical asymptotes. Let's see. If I go out here to 2 pi, I've got a vertical asymptote there. And I've got a vertical asymptote at 0. I could do a second cycle really easily over here by doing another vertical asymptote at negative 2 pi. My period is 2 pi because it was adjusted by that value of b. So there's one cycle. We're doing a second cycle. All right. Center, quarter functions. Well, center is at 0, so that's easy enough. For both of those cycles, I'm doing 2 cycles of cotangent. Center is at 0. My quarter function values are going to be at 3, and I'm doing positive cotangent, which is decreasing. So if I look at this first cycle I sketched between 0 and negative 2 pi, I'm decreasing, so I start high, finish low. This quarter function value is going to be at positive 3. This one will be at negative 3. Oh, I did a weird, funky little curve thing because it got stretched and I messed it up. I'll do better on the next one, hopefully. Okay, so a second cycle, starting high, finishing low, so that I have this nice decreasing cotangent function value. That one looks a little better. It doesn't have much of a curve because it got stretched vertically. What are these values on my x-axis? Well, half of 2 pi is pi, and then we got pi half and 3 pi halves. So negative pi, negative 3 pi halves, negative pi half. That means this quarter function value is at pi half 3. This one is at 3 pi halves negative 3. That's 2 cycles for my cotangent function. Okay, so here we have one where we are finally adjusting our center. So for this graph, center is moving up 2 units. Let's just start there. If center is going up to 2, then this is my new center. C is 2. So center is that line y equals 2. A is just 1. So when I do my quarter function values from center, I'm just going up to 3 or down to 1. Those are going to be my quarter function values. And then I have a value of 1/2 again for B. The last graph we did, B was 1/2, so we know what that's going to do over here. We know that my period, when I set that up, is pi over 1/2. My period becomes 2 pi. I'm graphing positive tangent, which is an increasing function. And the vertical asymptotes for tangent start at bx equals plus or minus pi half. Tangent is undefined at the odd pi halves. So when I plug in this value for b right here for my vertical asymptotes, plus or minus pi half, to solve for those vertical asymptotes, I multiply everything times 2. X equals plus or minus pi. Positive and negative pi are going to be the locations for my vertical asymptotes. That's going to give me my period of 2 pi. So let's do that. We'll just do one cycle for this one. We'll go out to positive pi, back here to negative pi. Those are my 2 consecutive vertical asymptotes. I've got center here at the y-axis, quarter values here at negative pi half and positive pi half. And let's graph our tangent function. Positive tangent is increasing with a value for a of 1. So from center, I'm just going up and down 1. In which direction am I going? Well, I need to go so that I'm increasing. So I'm going to start low, finish high. Those are my quarter function values. Down 1 from center, up 1 from center. There's center right there. Alright, we get our curve. We got a better curve going here, huh? Okay, so important parts of the graph. I graph my vertical asymptotes. Have to, have to, have to. Graph center if it's not on the x-axis. Mark my quarter values and my center. Make sure I use A to figure out where those values are. If I'm asked for coordinates, this one would be negative pi half 1. This one would be positive pi half 3. And the center point is 0, 2. 0 radians, the value of the function is 2. All right, excellent. Let's look at, we've got one more graph to do together. Yeah, one more graph to do together. And then we're going to write equations for graphs. Get a little bit closer. Okay. What have we got going on here? We've got a center. We've got center shifted up again. Oh, we've got a phase shift in here. We've got a phase shift. So we get to deal with a phase shift, an example together. All right, A is 1, B is 1, C is 3. What is D? Well, since B is 1, we don't have to factor anything out. D is a negative pi half. Remember that expression starts as x minus D. So since this is x plus pi half, I plugged in a negative pi half. So my phase shift is going back to the left. Make sure that you tell me which direction we're moving. There's my center. All right, let's go. Let's see. We've got a center at 3. 1, 2, 3 is going to be my center. My value for A, so my quarter function values will go up and down 1 from center. So my quarter function values are going to be at 2 and 4. We're graphing positive cotangent, which is a decreasing function. Just to keep that in mind. My period is just going to be pi because B is 1. So I'm not changing the period of this function. I'm graphing cotangent, so my vertical asymptotes are going to start at bx equals 0 and bx equals pi. B is just 1. So my vertical asymptotes start at 0 and pi, which works for my period, but I have a phase shift. So I have to take these equations for these vertical asymptotes and I have to apply my phase shift. My phase shift is a pi half to the left, so I'm going to subtract pi half from each of those equations of vertical asymptotes. So I have x equals negative pi halves, and I have x equals positive pi half. This is where my vertical asymptotes need to end up falling. They're still pi radians apart, so my period is still correct. But I've taken my typical cotangent function graph that would be over here at 0 and pi, and I've shifted it pi half units to the left. That's my phase shift. I've started at 0 and pi. I've shifted it pi half units to the left. So that my consecutive vertical asymptotes are now at negative pi half and positive pi half. Still have the same period that I need, but we have shifted it to the left. So we've taken our cotangent function, we've shifted it up, and we've shifted it up, and we've shifted it to the left. Okay, need 4 intervals between negative pi half and positive pi half. Center is here at 0. My quarter function values, half of a half is a fourth. We are graphing positive cotangent, which is decreasing, so we're going to start high and finish low. My value for A is 1. So there's my center at 3. First quarter value is going to be up here, 1 higher. Third quarter value is going to be over here, 1 lower than center. And when I connect them with a nice curve that approaches my vertical asymptotes but does not cross. There we go. All right. Hopefully those are enough examples to let you work your way through the My Math Lab problems, any written assignments that you have. and at least let you know what questions you need to ask a tutor or ask me, or go through the ask my help me solve this or show me an example in my math lab to get help. All right, last thing for this section. We are going to write an equation for each graph. As I mentioned before, you can do multiple equations for each one of these. We're going to keep it simple, and we're just going to do the most basic equation for each of these graphs. I could do, so this is an increasing function. It could be positive tangent or it could be negative cotangent. Same thing here. This is an increasing function. It could be a positive tangent function or a negative cotangent function, depending on if I want to deal with phase shifts. We're not going to do phase shifts. We're just going to keep a basic equation. We're going to be basic here, as basic as we can be without doing any fancy stuff. Well, we've got an increasing function. It is split over the y-axis. We've got vertical asymptotes at negative and positive pi half. That is my setup for a tangent function, for a positive tangent function. Now, if I wanted to make it negative cotangent with a phase shift, this is positive cotangent with a phase shift. If I made it a negative cotangent with a phase shift, I could do an equation for that as well. But we're just going to keep it basic. We've got a positive tangent function graph set up here. No phase shift needed. The period is pi, so no value of b other than 1 is needed. What about a? Well, I see that when I look at my quarter function values, I'm at positive and negative 3. So I know that a would be 3. And a would be the coefficient of my function. So we've got tangent. We're going to make that a 3 tangent of x. That is the most basic equation for this function. Now, if I wanted to go the cotangent function route, like I said, it's increasing, so it would be a negative cotangent. Still has a value of a is 3 because that quarter function value would still be 3. But instead of x, I would have to thought about taking this and shifting it back to the left pi half. So this expression would be x plus pi half. That's an alternate equation for this function. All right, now let's look over here. This is increasing. It is not balanced on the y-axis. It's got vertical asymptotes at 0 and 2 pi. So if I don't want to consider a phase shift, I will make this cotangent, but it would need to be a negative cotangent. So this could be a negative cotangent without a phase shift. But the period here is 2 pi, not pi, which means I started with pi over 1/2 to get that 2 pi. So this is the value I need to plug in for b. What else? Do you see anything else? Ah, my center value is at 1. So c is 1. We said b needs to be 1/2. What about a? Well, if my center is at 1, my quarter function values are at 0 and 2, so a is just 1. So we've got a negative cotangent without a phase shift. We've got a center that is different and a value for b. So y equals, we shifted up 1, so 1 plus, a is just 1. Negative, ooh, let's make that 1 minus. It needs to be a negative cotangent. Let's make that 1 minus cotangent of 1/2 x. There's my value, b is 1/2. What if I wanted to do it with tangent? Well, tangent, it would be positive because it's increasing. Would still need that center up here at 1, but I would need a phase shift, right? So positive tangent, 1/2 would be b. My phase shift would be pi half to the right, so that would be minus pi half. With this factored out, if I decided to multiply that in, I could write it as 1 plus tangent of 1/2 x. Oh, wait. This is wrong for D because of this being 1/2, that needs to be pi, not pi/2. We have a phase shift of pi units, because if we wanted it to be a period of 2 pi and be balanced on the y-axis, our vertical asymptotes would be negative pi, positive pi, so that when I shift it over, I have to shift it pi radians. So that would be minus pi, and then if I distribute this 1/2 in, it's minus pi/2. There we go. So these are two equivalent ways to write an expression for this graph, or an equation for this graph in terms of tangent.